Okay, now let's continue our class with slice indexing. In this case, if you want to extract some data separately from the existing matrix, in such cases, we can perform this slicing. We have seen this slicing operation already in list data structure, right? When you wanted to extract some specific elements in index numbers, then you can use this slicing operation. Now the same slicing operations in the same way by using the colon symbol, mentioning the starting index number, ending index number, and the step. Same in the same way we can use the slice operations here also related to this n-dimensional arrays. So let us first create a two-dimensional array with 3 by 4 dimensions. Okay, so it is 3 rows, 4 column matrix. When you execute this, you can see that the 3 row, 4 column matrix is created. You have to notice these brackets, number of brackets what we are using. Array function always expects one single argument. That is, whether it is a single dimensional array or multi-dimensional array. If it is a single dimensional array, it takes a single list. But if it is a multi-dimensional array, it takes multiple lists in one list. So it is list of lists that has to be passed as parameter to array method. Now we are creating a 3 by 4 matrix by using this NP array, and that matrix is created. Now if you want to slice, means if you want to extract only some elements from this matrix, then you can perform the slicing operation like this. Now you can see here we are using for the row what elements what rows have to be in the rows location, what elements have to be retrieved, and in the column location what elements have to be retrieved, that we have to mention. Now initially we are mentioning how many rows have to be retrieved. Because we have been given the starting point, we can consider it as 0, and the ending point is given as 2. So you have to take the index number 1 before that. So 1 is the index number. So we wanted rows from 0 to 1. So we take the 0th row and the first row. Okay, now among these rows, what columns you are interested in to retrieve them? You are interested in the first column and the second column in order to retrieve. Third column is not required. That is given as the endpoint and one index number before that is taken. So you are interested in first column and second column. So what is the first column here? 12, 22 and 32 is your first column, and 13, 23 and 33 is your second column. But initially we have reserved only 2 rows, not all the rows. We have given here to select only 2 rows. So from these 2 rows, you are trying to take only the first column elements and the second column elements, which will give us 12, 13 and 22, 23. So when you execute this, you are just extracting the elements and placing it in a variable or an object, and you are executing this. When you print that, you can see that the first row and second row are considered, and the 0th row and the first row are considered, and first row and the second column are considered. Only those elements are retrieved. This is how slicing works. Now you can also retrieve some element and try to modify it by using this slicing operations. Now in this case, you have sliced out a part. You have sliced out a part from this matrix. Say we have the elements like this: 11, 12, 13, 14. 21, 22, 23, 24, 31, 32, 33, and 34. These are the elements we have. Now we have sliced this part. Now we can also modify this part of the matrix. If you want to perform any updations to the values in this sliced matrix, you can do that by using modification operation. See here we have referred to 0th row, 0th column of this sliced matrix and we are assigning 1000 to it. We have taken from this sliced matrix, we are accessing 0th row, 0th column element. So what is the 0th row, 0th column element? 12. Now to that location, we are replacing it with 1000. And when we print that before and after from the original array. You have taken the slice to perform the modification, but you are printing the value in the original array. Why is this required? Just to show you whether any operation performed on a slice of the matrix will it be saved to the original matrix or not. In order to show you that, we have taken this example. Now, if you print initially in the original array, what is the 0th row first column element? It is 12. Now, after taking the sliced matrix and perform the modification on this 12, in the slice, it is 0th row, 0th column. When you perform that modification and print it from the original matrix, you can see that the element is modified. So what we understood from this is, though we slice out some data from the original matrix and perform modifications to the slice, the same modifications will reflect to the original matrix also. So when you display the original matrix, you can see that this second element is modified. It stands modified. The change reflects. The change made to a slice reflects in the original array also. Okay. Now let us create another multi-dimensional array, or we can call it as two-dimensional array. Now, extracting the elements from this matrix, we can extract it as a rank 1 view or a rank 2 view. Means you can extract it as a one-dimensional array or a two-dimensional array. Let's see how we are doing it. See, in this case, when we are performing the slicing, in the first index, we have given just the index number. We haven't given the slicing operation. We have just given the index number. Notice that. And for the first row, get all the columns. Means you are trying to extract this part of the array as a one-dimensional array, not as a two-dimensional array. If we want it as a two-dimensional array, you have to use the slicing operation in both the row index and the column index. But here in the row index, we are just using the index number directly, and in the column index, we are using the slicing operation. Means you are selecting all the columns, you are selecting all the columns of the first row. So what will be displayed here? 21, 22, 23, 24 as one list. Okay, and its rank will be 4 comma, because it is a rank 1 view. We are viewing it as rank 1 matrix, one dimensional matrix. So let's execute this and see. You can notice that the first row with all the columns is extracted, and notice the difference when we are taking the shape of this sliced out matrix. When we are taking the sliced out array, what is its shape? It is taken as 4 comma, 4 columns with one single row, and it is treated as one dimensional matrix. So we have only the dimension of the column, means actually the number of elements in the one dimensional array that is printed. Now let us take the same thing by using a rank 2 view. Okay, so in the row index, we are taking first row. We can denote that with 1 to 2. 1 to 2 means only one row will be considered. Now the first row of the matrix is taken with all the columns. In the previous case, we have given the index number, but in this case, we have given the slicing operation in the index number. That is why whatever is retrieved now from the matrix is taken as a rank 2 matrix, two-dimensional matrix, right? So it gives the same output, but the shape will be different. Notice the difference. When you display this, you can notice that 21, 22, 23, 24, all these elements are enclosed within another set of brackets, right? It indicates that this is a rank 2 view. Here you can notice one single set of brackets are used. Here two pairs of brackets are used, indicating it is a two-dimensional matrix. And you can also notice the shape of this sliced out array. It has one row with four columns, right? That is the difference between a rank 1 view and a rank 2 view of the matrix. Now, if you want to get some elements separately and perform some kinds of operations, let us see what different kinds of operations we can do with this slicing. In this case, from this array we are using, right? From this array, you take all the rows, but only the first column. All the rows and only the first column means what do you extract? All the row values, but only the first column. So you get the values as 12, 22, and 32. All the row values are extracted, right? But only with respect to first column. This is 0th column, this is first column. So 12, 22, and 32 are extracted. Now when you take and those 12, 22 and 32 are stored in column rank 1 object, and now use the same array, and here you are extracting all the rows, again the first column values. Now you can see that again the same values you are extracting. But in the previous case what we are doing, we are giving the index number with the slicing operation and with a single index number. And in the second case, we are taking the slicing operation in both the index numbers. So when you want to refer to that sliced out array as a rank 1 array, you are giving an index number. If you want to refer to it as a rank 2 array, you are giving slicing in both the index numbers. Okay, so this is the difference. You can notice the difference very clearly. In the first case, 12, 22, 32 is extracted, but the shape is just 3 comma, indicating rank 1 view. And in the second case, same data is extracted, but in a rank 2 view, making the dimension to be 3 comma 1. Now let us create another array, this time having 4 rows and 3 columns. Now let us extract some specific values from this array. Now let us take a object column indices and create an array with values 0, 1, 2, 0 and store in column indices object. Now a one-dimensional matrix is created. Now when you print this, what are the column indices that are picked will be printed? Means I'm trying to say that you can have different arrays zipped together in order to resemble the rows and column numbers from using which you can extract the array elements, right? So when you as you go on, you will understand more clearly. Now in this case, we have created column indices, one dimensional matrix with values 0, 1, 2, 0, and for creating the row indices, we have taken a range. NPA range will create indices from 0 to 3. A range works same as in for loop, but here we are using it as a range because it belongs to the Numpy arrays. There is some difference between the names of this function. Now when we use np.arange for list of values 0, 1, 2, 3 are assigned to this row indices. Now let us see what are the column indices 0, 1, 2, 0 that we have created as one-dimensional array, and row indices that we have created using a range function. So it is 0, 1, 2, 3. Now let us use a function called as zip. Zip function will make us connect two lists and refer to the simultaneous points. Say list 1's 0th index and list 2's 0th index can be connected. List 1's first index number and list 2's second index first index number can be connected by using this zip. Okay, now we are using this zip to zip up these two arrays, this array and this array, so that 0 0 will be connected, 1 1 will be zipped together, 2 2 and 0 3 will be zipped together. Now let us take a for loop. For row comma column in this zip, now what will happen? Row refers to 0, column refers to 0. Now again in the next iteration, row refers to 1, column refers to 1. Next iteration, row refers to 2, column refers to 2. Next iteration, row refers to 0, column refers to 3. Like that. For that, we are just printing to show what will be the values after zipping these two one-dimensional arrays together. Okay, so you have 0 0, 1 1, 2 2 and 3 0. Now, let us use them as index numbers to retrieve the values from the original matrix. So, we are interested in index number 0 0, 1 1, 2 2 and 3 0, right? So, that we are using as index numbers. So, what will be retrieved? 0th row, 0th column element will be retrieved, that is 11, and first row first column element will be retrieved, that is 22, second row second column element will be retrieved, that is 33, and finally third row 0th column element, that is 41. All these will be retrieved, just to show how we can perform creation of arrays, use them as index numbers and extract the elements. Okay. So when we extract the element, you can see that 11, 22, 33 and 41 are displayed, right? Now, if you want to make some changes in these index numbers, you can still do that. You can use row indices, comma column indices, means all the elements in 0, 0, 1, 1 index number, 2, 2 index number and 3, 0 index number. All these will be added a value 1000. Okay, so 11 becomes 1011, 22 becomes 1022, 33 becomes 1033 and so on. And after that, when we print, you can see that all these elements are modified: 1011, 1022, 1033 and 1041. This is how we can create index numbers as a set and then apply some operations at a time to the matrix elements. In the next class, we'll see about Boolean indexing.